Hi, good evening and welcome to this quick demonstration. So very short, I'll actually be using this SenseItAll to do a measurement on the lead in a domestic tap water situation. So I've got a lead sensor here. I'll put it onto the SenseItAll meter and I will prepare a sample that I took earlier on. So I'll come back to that in about 30 seconds, but just bear with me when I just give a quick introduction to why we're doing this. So we've been around the house, we've collected water from various taps, and I'll describe where those taps are located. So 2 taps on the ground floor, 1 on the middle floor and 1 on the top floor. Now what I want to do now is start preparing one of those samples, and I'll do a live preparation stud of that sample and a live run of that sample, and in the meantime then I'll talk about the rest of the data. So let me just go to here very quickly. Everything's been done live now. So I've got the little vial. I'm just going to take 100 microliters of the water. Now the problem we're solving here is that most of the time people can't actually do this very fast, low cost, rapid testing. In fact, they're collecting samples and then having to put documents around those samples and send those samples out to laboratories, and it puts a lot of administration onto the collection of the sample. The sample will start costing you, by the time you've put proper administration around it, like something like $200. So I've prepared the sample just now. So the sample preparation took me, 20 seconds. I'll just shake those two things together, which I've just done. I'm just going to put a drop onto the lead sensor here on the SenseItAll platform. So I'll flip this little vial open. I'll just take a quick sample now. Sample goes on there. And we are done there. Now the app is in Bluetooth connection with a meter. I've already named, whoopsie-daisy. I've already named the sample so I can find it later on. Top floor I've called it. I'll just go continue. The dilution I did was 1 in 2. You saw me do that. I'll go start and off it goes. So that takes about 4 minutes to run. So that'll be running in the background now. And now I'll go back to and you'll be able to see it kind of running here, but it'll be very small. All right, so what we've done is we've got a 3-story house, 2 taps on the ground floor, 1 tap on the middle floor and 1 tap on the top floor. And at the moment, whilst I'm talking, we're running the sample for the top floor. But let's just have a quick look where we're at. So with the ground floor, we took a sample, we tested it for lead and copper. The lead, when it says low, means it's kind of below 5 ppb, parts per billion. Now, the copper is often reported in ppm, parts per million. So when we test the water on the ground floor and it says low, it means the lead is below 5 ppb, parts per billion, and it means that, and the copper, we can pick it up at 300 ppb, but that's probably not a problem, because when people are talking about the limits or the regulatory limits for copper, they're often using the units of ppm, parts per million, which is greater than ppb. So this 300 ppb is 0.3 parts per million. When we look at the raw signal, and you'll see this in a bit, that actually we can just about see the copper and we really can't see any lead, but the copper's, once we process the signal, then we can see the copper quite clearly. Now we also have a sample from a ground floor bathroom. Both copper and lead are low here, and when we look at the signal, it's very hard to see either copper or lead in that particular situation. So those are both, let's say, low. Now on the middle floor, the lead is actually reported as low, and the copper is actually reported at 667 parts per billion. Again, the kind of regulatory requirements talk about parts per million, so we are below the sort of regulatory cutoffs. If we look at this, we don't see lead, but we actually can see copper. Literally by eye, we can see the copper. So that 667 is reflecting the fact that the copper is there. And when we do a sort of a signal extraction, then we do get quite a big signal for copper. And now where we're coming to is the top floor. So at the moment, while I've been doing that, now what's useful about this is it's actually quite, when people are normally doing surveys of properties or facilities, they kind of have to be very careful about this sample came from here. The sample is never done there and then. So with this one, it's quite nice because the administration of doing this study is quite easy, because I took the sample, I prepared the sample, I put it on the sensor, I get the results. So that kind of administration and that understanding of where that sample actually came from is much easier. Now, when you fully count in the cost of actually doing, these are effectively tap tests. You may be talking about, like, if you've really looked at the true cost of the test, you're looking more like £200, €200, $200. Whereas the test here, I think if you fully kind of account for all the various costs, the buffers, the sensor, etc., then you really are talking about more like €5, £5, £5 per test. And we also get the real convenience of the speed as well. So we're about the step 1, we're about 26 seconds off it. When that's complete, then we'll go to step 2, and then we'll actually get the result there and then on our phone. But what's neat is we get the result on our phone, so you can just essentially, you could write it down, but by the way, it's also saved to the cloud automatically. You just have that sort of super easy convenience of having it there and then. So now it's actually doing its analysis. This will take just under 15 seconds, and then we will get a result on the phone, and the results will also be saved to a cloud system as well. And I'm just navigating on my computer because just to show you what that will actually look like. So it's doing the analysis now. It's sending the data to the cloud, and then it'll sort of say upload complete and give us a result, and then we will know the lead. Now, what's interesting is that you would really, most of the time I think we can be quite naive and not think actually there isn't any copper or lead in our, let's say, drinking water. But in fact, I think the further you come up, so you've got the sort of water mains into the house, but of course then you're distributing that often through copper pipes. So in fact the copper can be higher. So what I have now is a result. So it says lead is low and the copper is 14 ppb of 417. And it also says upload complete. So let me just kind of show you what upload complete actually means. I will share my screen with you here. Oops, Daisy didn't mean to go there, but I can show you demo, my machine, the top floor result, which I can see there. I'll just go and grab it and go and have a quick look at this. This is what's really cool, is that if somebody's remote, they can immediately get the results. They also don't have to, if somebody's even on site, they don't have to write it all down. It will all be saved, and you can just about see the copper there, and that's what it's picked up there. It's picked up the copper, but there's really no lead to be picked up in this sample. So what's really cool about this is, so you get the evidence of what is actually going on. And so there is, very little, let's say, lead in this water, but I can see the copper, and I can report the copper at 417 parts per billion. But as I say, they really count copper in parts per million, and I will look up, depending on your country, your region, then the regulatory requirements will be at different places, but I suspect where I am that this is considered safe. So I want to just kind of finish with this and say that if you do have any questions regarding the rapid detection of lead in samples like drinking water, and as you can see in this one, I was able to survey the house and actually check out 4 taps, and I did it all myself just this evening, really no problems. If you've got any questions, don't hesitate to reach out to us. Okay, thanks very much.